Good evening, everybody. Good evening. Good evening, everybody. Good evening. Good evening. Yes, quickly join the class. Quickly join the class. Join the class quickly. Yes. Today we will discuss about a common topic, a new topic. So, which is common for both class 9 as well as class 10. A new topic will be discussed. So, quickly join the class. Join the class quickly. Probability, most important part. So, no deletion in the chapter probability for the board examination 2021. So, just see the video till the end to get the complete idea about the probability. So, first of all, what probability we are reading in class 9 and class 10? That is only a classical probability, or we can say theoretical probability. Classical or theoretical probability. We are not reading about the empirical probability. We are not reading about empirical probability. Classical or theoretical probability we are reading in our syllabus of class 9 as well as in class 10. So when we are discussing about the probability, first of all, sometimes we may say probably it may rain, may occur, may not occur. Probably somebody may secure CGPA 10 in the coming board examinations. So, probability leads to certain uncertainty, may occur, may not occur. So, we can say also probability is the game of chance. Game of chance. So, here, event is uncertain, may happen, may not happen. So, in probability classical probability. So, it is classical probability. Classical probability. So, classical, or we can say theoretical. Classical, or we can say theoretical. What are the different terms related to probability? First of all, we should know about the terms. So, first terms. Random experiment results on two or more known outcomes. So I will explain it now. What is the meaning of random experiment? Random experiment. Experiment conducted under when the coin is tossed, then what will happen? Either it will come or tail will come. If a Ludo dice is rolled, then what will come? Either 1, 2, 3, 4, 5, 6, anyone will come. So we can say this is a random experiment. This is a random experiment. Now, yes. Am I visible? Am I visible to all of you? Yes. So, little bit price. Dice means standard dice. Now, second thing is sample space. Second one is sample space. Sample space. Sample space. So, what is the meaning of sample space? In a random experiment. In a random experiment, all possible outcomes obtained is called sample space. It's called sample space. So now see, if we are doing an experiment, we have some outcome. Suppose, now see, this is one coin. This is the coin. This is the tail part. This is the head. Head 1, head. The emblem of Ashoka, head. We are telling you this is head. And where 5 is written, this is the tail part. So by tossing the coin, either we'll get head or we'll get tail. So what is the total number of outcomes? Possible outcomes, head or tail. Total 2. So sample space is 2. Now we'll tell, suppose Ludo dice. You all have seen Ludo dice. Ludo dice, standard Ludo dice. It has 6 faces. 6 faces. 6, 3, 4, 1, 2, 5. These are written in different faces. Ludo dice. So in Ludo dice, if we rolled it, then I may get 1, 2, 3, 4, 5, 6, any one of it. So total outcome is 6. So that is your sample space. Now in pack of cards, suppose cards are there. You know about the cards. So this is a pack of cards. Joker is not a card. First of all, get clarified. Joker is not this is Joker. Joker is not a card, not considered in the pack of playing cards. So after Joker, we have 52 cards. 52 cards. We have 52 cards. See, 52 cards are there. So this is a pack of cards. Pack of cards. Details about the cards I will tell. It has 4 type of, divided into 4 categories like heart, diamond, spade, club, then which one is jack, queen, king, ace, number cards, face cards, everything I will tell. So one by one I will explain about the cards, dice, coins, double coin, 2 coin. So how to find out the sample space? So first of all, remember, sample space means the total outcomes. The total outcomes. So now see, sample spaces we are getting. Now in turn we can say that in probability we have to perform one experiment, or we can say event. For that event, another term is related. That term is your what? Experiment. Random experiment. Then sample space. Then your favorable outcomes. Which outcome is favorable? Suppose you want to get a head, one tossing coin. So favorable outcome is head. Suppose you want to get tail. So favorable outcome is tail. So one by one I will tell. So first click me this one. Now then equally or likely outcomes. Equally likely outcomes. So equally and likely outcomes. So what? In a random experiment, suppose in a random experiment, if the possibility of each outcome is same, it is called equally likely outcome. Equally likely outcomes. So now tell me, when one coin is tossed, head may come, tail may come. Equally and likely. Unbiased coin. Coin is not biased, not defective, unbiased. So always we are writing unbiased coin. So head or tail, equally or likely. So equally or likely, rolling a dice. When 1, 2, 3, 4, 5, 6, anyone will come, equally or likely. Now, see, suppose in an examination, out of 100 mark, in examination out of 100 mark, some students secure your, let's say 75 by 100. Another student secured 85 by 100. Now another student secured 100 out of 100. Somebody secured 35 out of 100. One student secured 0 out of 100 also. So these are the marks obtained by different students. Marks obtained by different students. So when the marks obtained by different students are given, 0 by 100, 35 by 100, 75 by 100, 85 by 100, 100 by 100. Now see, what is the value of 0 by 100? 0 by 100 is 0. 0 by 100 is 0. Now what is 100 by 100? 100 by 100 is 1. Now this is your 0.35 in decimal. 0.35. This is your 0.75. This is your 0.85. So we can say what? Probability of an event lies between 0 and 1. Probability of an event lies between 0 and 1. So we can here conclude 0 less than equal to probability of an event PE less than equal to 1. 0 less than equal to PE less than equal to 1. Maximum value 1, minimum value 0. Maximum, this is maximum. Maximum, this is your minimum. Minimum. Then other lies between 0 and 1. So 0 less than equal to P less than equal to 1. Probability of an event lies between 0 and 1. Maybe 0, maybe 1. So equal sign is given. Maybe 0, maybe 1. So when 0, when 1. If 0, then what is it called? If 1, what is it called? So one by one, I will tell about the probability of the event. Now see, so probability of the event, already I have written here, is lies between 0 and 1. Now removing all these things from the board, only this part. So now see, when we are telling PE, probability of an event, PE means probability of an event or experiment also can say PE. So PE is equal to 0 means what? Means impossible event. Impossible event. So impossible event, not possible. How? Suppose getting a score of 7 in a single throw of Ludo dice. Now see, in Ludo dice, 1, 2, 3, 4, 5, 6, these are the outcomes. If you rolled it, one single Ludo dice, roll it, then 1, 2, 3, 4, 5, 6, anyone may come. Anyone may come. But 7 will not come. In a single throw of a Ludo dice, getting a score of 7, in a single throw of a Ludo dice, a single. So, it is impossible. It is impossible. So, impossible event. Suppose you have taken red ball, blue ball and green ball. Red ball, blue ball and green ball. It is asked, find the probability of getting a black ball. No black ball. So, probability is 0. So, I will tell about the numericals one by one. About the numericals related to cards, related to dice, single dice, double dice, everything I will tell. So now, P is equal to 1. PE is equal to 1. So that means sure event, sure must occur, must. Now see same thing, getting a score less than 7 in a single throw of a Ludo dice. So getting a score less than 7, maybe 6, maybe 5, maybe 4, 3, 2, 1, anyone less than 7, not given what is. Less than 7, 1, 2, 3, 4, 5, 6, anyone may come. Suppose we will throw the single Ludo dice, then also we will get 1 or 2 or 3 or 4 or 5 or 6. Anyone. So this is sure. Anyone will come. Definitely it will be less than 7. Definitely it will be less than 7. So it is sure event. Okay. If impossible, 0. P is 0. If sure, P is equal to 1. Other remains lies between 0 and 1. So probability basically lies between 0 and 1. If 0, impossible. If 1, sure event. If 1, sure event. Okay. Now I'll tell you about the complementary event. Complementary. Okay. Complementary event. Now see, complementary event. Complement. You know, complementary event. What is the meaning of complementary event? What is the meaning of complementary event? Now let us see. Suppose one event that is PE. Suppose this is PE. Probability of an event. This is probability of an event. So complement of PE is equal to P E bar. Or we can say P naught E bar or P naught E. So now PE plus P naught E is equal to 1. Always PE plus P naught E is equal to 1. PE plus P naught E is equal to 1. Suppose probability to find out PE is equal to 1 minus P naught E, or P naught E is equal to 1 minus PE. So this is the method of getting the complementary event if event is given, or finding the event if complementary event is given. Okay. So now see the example. Suppose it is given probability of winning a match is 0.85. What is the probability of losing the match? So see, winning opposite losing, complementary, winning, losing. So winning the match is 0.85. Winning 0.85. Then what is the probability of losing the match? So PE 0.85. Then P naught E 1 minus PE. So 1 right here. 1 minus 0.85 is losing. P E bar is equal to means probability of losing, that is equal to 0.15. This is the answer. So probability of losing the match will be 1 minus 0.85 is 0.15. So probability of losing the match. Okay. Now see, forget about this. Now come to directly to numericals. How to solve the numericals in the probability questions. So now see, what is very important. So now see the questions. How the questions are coming. How we are finding the probability. How we are finding probability of an event. So we can write PE, probability of an event. This is probability of an event is equal to number of favorable outcomes by total number of outcomes. So number of favorable outcomes by total number of outcomes. So now see, we'll take one example to explain it better. Okay. So now question is this. A bag contains 5 red balls, 7 blue balls and 8 green balls. It is mixed together and a ball is drawn at random. Find the probability of getting bit I a red ball, okay, bit double I a black ball, bit triple I, okay, not a red ball, not a red ball. And now bit 4, either your blue or green ball, Now question is given. Look at the question. Okay. Now see, a bag contains 5 red balls, 7 blue balls and 8 green balls. Now it is mixed together, randomly mixed, and find the probability of getting a red ball if one ball is chosen at random. Written a ball means one ball is drawn at random, is taken out from the bag at random. Okay. So now what is the probability of getting it? Now you know about it. So give your comment. Yes, give your comment. Very good. Good evening everybody. Sapna Sarit, Hiladri. Yes, give your comment. What is the probability of getting a red ball? Favorable outcomes. Red ball. PE. Number of favorable outcomes. How many red balls? Yes, 5 red balls. Total how many balls? 5, 7, 8. So 5 plus 7 plus 8, or initially we can add it. So 5 by, that is 20, is equal to 1 by 4. So probability of, we can write here, probability of getting a red ball is equal to, here you like 5 by 20 is equal to 1 by 4. Like this, you will write like this part. This is for explanation. This is for explanation how to find out the total number of outcomes. Okay. So, probability of getting a red ball, or you can directly write PE. PE. Yes, very good. 1 by 4. Very good. Good. Now, probability of getting a black ball. Black ball. Black ball. So, is there any black ball? See, black ball. Give your comment. Give your comment. Very good. 0. Yes, Swapna Sarit, your answer. 0. Yes. Very good. 0. Good. Bunty, your answer is 0. Very good. Yes. So, yes, impossible event. Very good. Very good. Yes. So, this is 0. 0 by something is 0. So, 0 directly 0. Impossible, because red ball, blue ball and green ball are there. Red, blue and green. No black ball. So, no ball will be black if drawn at random. If drawn at random. So, probability is 0. So, we can write P here is equal to 0. Now, see, this part I am removing. Find the next one. Okay. Now, not a red ball. Not a red ball means what? Red ball, P, a red ball. A red ball is equal to 1 by 4. Already we have obtained 1 by 4. So, P, not a red ball. Not a red ball is equal to 1 minus 1 by 4 is equal to 3 by 4. Like this, you can find out. Not a red ball. Okay? 1 minus 1 by 4. Or not a red ball means what? Not a red ball means maybe blue or green ball. Blue or green ball. That is given. Either blue or green. So here we can find out blue 7 plus green 8 by 20, total 20. So 15 by 20 is equal to 3 by 4. So we can conclude that not a red ball. Not a red ball means what? Not red means either blue or green. Either green or blue. So both probability same. Not a red ball means either blue or green ball. But we will solve according to the question given. We will solve according to the question given. Okay. Now move on to the next one. Next question. Okay. So now move to the coin. Directly double coin. Double. 2 coins. Head and tail. So now see. 2 coins are tossed simultaneously. Find the probability of getting head only, double I, one tail. Okay. Now we know about the coins. See, coins. Tail, head. 2 coins. Now see, 2 coins are there. 2 coins. Now 2 head. So now see, 2 coins means coin, head, tail. 1 coin, head, tail. Again in this coin we can get head, tail. Here also head, tail. So now total outcomes is equal to what? Head. It will become head. Now head tail head, tail. So how many coins? Two coins. So sample space or total outcomes, total 4, because one has two outcome, two coins, 2 square, 4 outcome. If 3 coins will be there, 3 coins. Now see, 3 coins, this part I'll see, 3 coins, then total outcome is equal to 2 to the power 3 is equal to 8. If 3 coins will be tossed, then total outcome will be 3. Like here, it will come head, tail, like dot, last to tail. So total 8. I am not writing in details because we have 2 coins. Now 2 coins, 2 square, 4, head, tail head, tail. Okay. Head only head. So we type P only head is equal to only head, no tail. So this one 1/4. Okay, 1/4, only head, no tail. Now one tail, double I. One tail. So one tail. Now see, one tail. Here is one tail. Here is one tail. Here is also one tail. 2 tails are there. Means one is there. When 2 is there, one is also there. So this is 3/4. So 3/4 is the answer. Here 1/4 is the answer. So by tossing 2 coins simultaneously, we'll get head only 1/4, one tail 3/4. Now come to the next one about single dice. Okay, dice. Now see about the dice. Dice has how many faces? 6 faces. You have seen dice, Ludo dice. How many faces? So 6 faces. Ludo dice, 6 faces. 6. Okay. So Ludo dice, 6 faces are there. Different 1, 2, 3, 4, 5, 6 are written. 6 faces Ludo dice. Okay. So now Ludo dice. Standard I have written Ludo dice. I have taken standard Ludo dice, or you can write only Ludo dice. So total outcomes 1, 2, 3, 4, 5, 6 is equal to 6 total outcomes. These are the favorable outcomes. We have to find out. Given, find the probability of getting beta E. A prime number, okay, double I. An even number, okay, triple I. A multiple of 2 or 3. Okay. These 3 questions given. 2 or 3. Now see. Yes, very good. Total outcome 6. Yes, if 2 dice is there, 6 square, 36 square. 3 dice, 6 to the power 3, 36 into 3, 216. So I will not go to 3 dice. Only we have to 2 dice, 6 square, 36. That second part. Now total outcome 6. Now here a prime number, favorable outcomes is equal to what? Prime prime number. Which one? 1 is prime? No. 2 is prime. 3 is prime. 5 is prime. So, probability of the event is equal to 3 by 6 is equal to 1 by 2. Okay. So, this is a prime number. Favorable outcomes. Now, even number. Even number. Now see. Favorable outcomes. Favorable outcomes. Outcomes. So, favorable outcomes 2, 4, 6. So, probability of the event is equal to 3 by 6 is equal to 1 by 2. Answer. Now, last one. A multiple of 2 or 3 favorable outcomes is equal to. So, 2 is a multiple. 3, then 4, 2 is 4, then 3 2 is 6, 2 3 is 6. Double will not write, one time will write. So 2 3 4 6. Now probability of the event is equal to 4 by 6 is equal to 2 by 3. 2 by 3. So this is the answer. So like this, in single dice, we can find out the different probability as per the question given. Suppose given probability of getting an odd number, you can find out like even number, odd number, composite number, like prime number, composite number, even number, odd number, everything question may asked. So today it is already we have spent 40 minutes for the class. So I don't want to longer the class. Thanks for watching the class. Good night. Thank you again for seeing. So see you in the next class with other part, double dice and cards, spade, club, heart, diamond, king, queen, jack, ace, colors, everything, honor cards, picture cards. So everything will be explained in the next class. Good night once again.